In this section, we're going to talk about the challenge problem. Actually, it's not talk about. I'm going to give you some example about the challenge problem and how do we solve it. What's the idea? How I do this? One is sine negative x times cosine negative x, and then cosecant negative x. So we first of all, if you see some negative inside of the sine, the trig function, the first thing you need to think about is the odd and the even function. I need to convert this. So sine is a odd function, so that means sine negative x is equal to negative sine x. Cosine is an even function, so it's going to equal to cosine x. Cosecant is 1 over sine. If sine is an odd function, so cosecant will be an odd function too. So this is equal to negative cosecant. Negative, negative gives them a positive. And then I will have sine x, cosine x. And the cosecant, I can write it as 1 over sine x. These two cross cancel, so I have cosine x. Then we are done in this one. So second example is when you see square. So the first thought is whenever you see square, you need to think about using the identity. For example, this one, 3 times sine cubed t cosecant t plus cosine square t plus 2 times cosine negative t and then cosine t. So again, let's clean things up one by one. If you see a cosecant, usually my first thought is I don't like these cosecant things. I would like to rewrite it into sine and cosine. That's always a nice thing to do. So cosecant is equal to 1 over sine. Okay, now this gives you a little bit simplified. And then I have a cosine square plus you see the negative. What do I say earlier? If you see the negative, the first thing is you want to rewrite this into some sort of take out the negative side outside by using the odd and even function. So cosine is an even function, so we have a cosine t and then times cosine t. Now let's simplify it again. So this is cubed and 1 over sine t gives you 3 times sine square plus this 2 is what? Cosine square. And then 2 times cosine square plus 1 cosine square gives you 3 cosine square. So factor the 3 out. I have a sine square plus cosine square, which is equals to 1. So your final answer is equal to 3. Again, one way to check it is using decimal. See what do we get. Rusty, so is 3 sine cubed x times cosecant x plus cosine square x, and then add 2 times cosine negative x times cosine x. Oops, why there's a use parentheses. Okay, they want us to use parentheses on the x. No, I think they want us to use parentheses for the square. So yes, if I do this, it will make more sense on the computer. And for this one, again, square them Almost there. This is 3. So look, this is a J9. What's this 9? Is y equals to 3. They overlap. That means these two are equal. So that means that such a complicated function ends up to equal to 3. Okay, now this one is very complicated. Even for me, I spent like 2 full sheets of a draft paper to solve this one. Here we are. Let's do it. So I have a tangent x over cosecant square x plus tangent x over secant x squared times 1 plus tangent x over 1 plus cotangent x, and then subtract 1 over cosine square. For me, how I want to work on this problem is I simplify term by term. So here is one term. I'm going to simplify this first, use different color. And then this is the second term. I'm going to use red. And the third term is quite straightforward. It's just 1 over cosine square, which is equal to secant square. So let's work on the first term. So the first term, how are we going to do it? We have tangent, cosecant, tangent, and secant. So the way I would do it is always turn this into a sine or cosine, because we're more familiar with this. So tangent is equal to sine over cosine. Secant is equal to 1 over sine square, plus the second term is, again, we write this into cosine and sine. Secant is equal to 1 over cosine square. Okay, let's do this side first. So in the first fraction, we need to simplify it by flipping the sine x squared on the top. So this is a complicated fraction. You want to simplify first. So I have sine cubed over cosine. For the second one, flip it. I have a sine x times cosine square over cosine x. Okay, that looks a little bit nicer. And since they have a common denominator, then we can put them together with a sine cubed at sine and then cosine square. Well, it's getting nicer now. Because on the top, they have a common factor sine. So we can factor sine out, which is going to be very nice. If we factor one sine out, we have a sine square plus a cosine square. This is nice. Why is that? Because sine square plus cosine square gives you a 1. So that means this whole complicated function end up to become what? These things. Let me highlight it. This part is equal to 1 by Pythagorean theorem. Let me use this one. Maybe it's more obvious. And since it's equal to 1, so that means it's just multiply itself, and then sine over cosine. Yeah, we get there. This is tangent x. Wow, that's the first term. We're done. By so complicated, we end up to be just a tangent x. Now, the second term. This guy, I'm going to use a red pen. Remember that the relationship is multiplication. Again, the first thing is I want to turn everything to become sine and cosine. Cotangent is cotangent x over sine x. Now, have you seen this as a complicated fraction? We learned this trick on, I think it's either 19.5 or 19.2. you need to find the common denominator on these 4 terms with 1 sine x over cosine x, and then another 1, and then cosine x plus sine x, and times all of the common denominator. In this case, you want to times sine x cosine x over sine x cosine x. Then I got sine x cosine x plus cross cancel sine square. In the bottom, same thing, sine x cosine x plus cosine x squared. It's getting nicer and nicer. Okay, let's continue. And let's factor the common factor out and see what happened to them. So if I factor the common factor out, I will have sine x and then cosine x plus sine x. In the bottom, I have a cosine x and then sine x plus cosine x. Well, this is very nice because these factors, they can cancel out because cosine at sine is equal to sine at cosine, because addition is commutative. That means a plus b equals to b plus a. So this is end up to become what? Another tangent, x. Well, we would write this, and well, these two are just 2 tangent x, so they end up to become tangent square. Okay, now it's the third one. Don't forget about this one. This is 1 over cosine x. So when we write it, use the green pen, is 1 minus secant square. So let's put it at the end. In fact, you should put it all in here, but again, I use different color to help me knowing that which one I'm working on, because I don't want to work on them at the same time. So sometimes I will copy them. When I copy them, I will make mistakes. Okay, so this is what do we mind about this? This is the Pythagorean theorem, right? They don't have the co one. That's the other one that without the co. So I got what? 1 plus tangent square equals to secant square. So that means secant, I can write it into 1 plus tangent square. Let me use the different color of pen so you know what I'm doing here. So this is still tangent x. Okay, now we move the parentheses, so I end up to have 1. That's it. Oh, -1, actually, -1. All of this complicated function end up to become just a -1. You can check your answer into GeoGebra, or you can use a different method to do it, especially this part. You may learn differently. If you took my class before, you will know this trick. Okay, let's do something else. Such as this one. I want to simplify tangent x plus cotangent x over cosecant x in terms of cosine x. Well, the first rule is what? We write all of this into sine and cosine. So the sine x over cosine x for tangent. Cotangent is cosine x over sine x. Cosecant is 1 over sine x. Again, you have 3 terms, so that means the common factor would be cosine x times sine x. So you want them to multiply this on every term. So I will have sine x squared plus cosine x squared over this one end up to just have cosine x. And then sine x squared plus cosine x squared gives you a 1. That's it. Then we're done with our simplifying. If you don't know this method, how to simplify it, you can just easily look at these two, operating these two first, and find the common denominator, and merge these two fractions into one, and then just using the division of a fraction to calculate the whole one. Also works. So that's it for this video. I know it's a little bit long and a little bit harder. So I suggest you try to pause it or do the simplify by yourself so that you know all the trick. Okay, see you in next video.